Given a dataset where the mean age is significantly higher than the median age, what might this suggest about the distribution of ages in the dataset? Explain your reasoning. When the mean age is significantly higher than the median age in a dataset, it suggests that the age distribution is right-skewed. This skewness indicates that there are a few older individuals who are significantly older than most of the group. These outliers pull the mean higher while the median remains closer to the middle value of the majority of the data. The median is less affected by outliers and thus gives a better representation of the central tendency in a skewed distribution. How would you interpret the impact of a high standard deviation in test scores on classroom teaching strategies? Provide an example scenario to support your analysis. A high standard deviation in test scores indicates a wide range of scores among students. This suggests significant variability in student performance, implying differences in understanding and mastery of the material. In response, a teacher might need to adopt differentiated teaching strategies. For example, in a math class where scores vary widely, the teacher could provide advanced problem-solving sessions for high achievers while organizing remedial groups to focus on foundational concepts for those who scored lower. This approach helps address the diverse needs of students, ensuring that each student can progress at an appropriate pace. Design an experiment to compare how the presence of outliers affects the mean and median in real-world data. What steps would you include to ensure that the experiment provides clear insights into these statistical measures? To design an experiment comparing the impact of outliers on the mean and median, you could follow these steps. Data collection. Gather a large dataset of real-world data, such as heights of individuals in a population. Initial analysis. Calculate the initial mean and median of the dataset to establish a baseline. Introduction of outliers. Introduce outliers into the dataset by adding extremely high or low values far from the current range. Recalculation and comparison. Recalculate the mean and median after the introduction of outliers. Analysis. Compare the changes in the mean and median to analyze how each measure responds to outliers. Documentation and conclusion. Document all findings and conclude which statistical measure is more robust against outliers. This experiment would help illustrate the sensitivity of the mean compared to the median when dealing with outliers, providing practical insights into these important statistical measures.